But I'm going to go ahead and turn this over to Rob and Trent. If we could, Rob, why don't you start us off with a minute introduction, and then we'll throw it over to Trent to give us an introduction of himself as well.
Yeah, sure. Thanks, Adam. So Rob Knockenhauer, the Director of Regulatory Affairs for Census Technologies. In my role, I basically work with clients that select census systems or others for that matter, and help advise on how to do complex operations. So in particular, BVLOS operations. So that's what we're going to spend some time talking about today. And my background is I started off my career as an engineer, worked with unmanned systems for a lot of years, undersea, ground-based stuff, and then finally in the air, and been working in the commercial drone space for about 10 years or so now.
Fantastic. Thanks, Rob. I'm Trent Sigurd. I'm the Partner Marketing Manager here at Auterion. And a little bit of background. I've been in the drone industry for 11 years, selling, supporting, and developing different drone systems for various companies. Currently with Auterion, and excited to jump into all things BVLOS today.
Awesome. Thank you guys so much. And I just want to remind everyone that this presentation today is brought to you by Auterion, who is partnering with us here at Census Technologies. And we're really going to dive into today about regulation around drones and also the technology piece that can help enable that as well. So I'm going to throw it over to Rob here to get us rolling, and take it away.
All right. Sounds good. Thanks, Adam. So, Part 107 is primarily the framework that most of the clients that we work with are working under, and certainly a lot of the drone industry here in the U.S. is operations are conducted under Part 107 for commercial drone operations. And so when Part 107 came out in 2016, there were a number of parts of the rule that were available to be waived. And so most of these you're probably familiar with here. So there's obviously we're going to talk about BVLOS. So in addition to BVLOS, there's operations over people, and then moving vehicles. And then there was operations at night, which was basically the main waiver that was granted to applicants until the rule came out in 2021 that basically eliminated the need to apply for a separate waiver for doing night operations. And then you have others that are a bit more obscure, in fact, that have never been used. I think so. 107.37 is the approval, or it could be an approval where you would actually have the crewed aircraft give right of way to the drone. And I don't believe there's actually ever been any of those waivers requested, or maybe requested, but certainly not granted. And so others here, it has to do with like where you're operating your aircraft from. So 25 has to do with if you want to operate your drone from like a moving vehicle, there's ways that you can make a request to do that as well. So I guess we can move to the next slide here. So all right, so we're going to talk about some of the common waivers that are granted. Common waivers of what we experienced. So what's happened in the past year or so, we've seen a big uptick in, you'll notice there's a lot of these waivers that we're listing here have to do with beyond visual line of sight. And so the FAA released a report back in March of 2022. Actually, it was an industry and FAA kind of co-produced report called the BVLOS Advisory Rulemaking Committee report. And some of the recommendations that were put in that report have been implemented by the team that have been evaluating waiver requests and doing these types of things. So one of them, which actually predated the report, was the tactical BVLOS waiver. And so what that is, that was a waiver that had been developed for operators that were doing things like bridge inspections, where you would use like a small aircraft and you literally just fly it like on the backside of a bridge or a building or whatever it is that you're inspecting. And so this is like a close proximity type of an approval. So these are used pretty commonly in, like I said, in bridge inspections. A lot of public safety folks are using it for getting access to different areas. And the public safety thing, one variation here kind of related to the tactical BVLOS and the drone as a first responder, is that many public safety agencies don't actually operate under Part 107. So what they're doing is they're actually applying for COAs under Part 91, so that it's a different avenue that they're taking, but the safety cases that they have to put forward are analogous to what you have to put forward in Part 107. The first one we've got highlighted here is the shielded waiver. So that is a waiver where, that is directly came out of the BVLOS ARC report, where the recommendation is that if you can operate your aircraft within 100 feet of either the ground, or in this case, as this graphic showing, power lines, you can basically, the likelihood of another aircraft being within that volume is so low that it is part of your mitigation strategy for air risk. And so in this case, we are able to run these, these low altitude operations, leveraging this low altitude shielding to do operations. In this case, well, we're showing here a 40-mile point-to-point, which is an operation that we've been approved to do at Census. Most of the operations that we run are practically a little shorter, between like 15 and 20 miles, where they're an out and back. The point-to-point has an added level of complexity, where when we run those operations, we have to have a pilot at both ends of the at the launch point and at the recovery point, because in the safety cases that we've developed for these types of operations, we've identified the highest risk part of the flight operation is within the landing and takeoff points. So, all right, so back to this here. The next one, going down the list here, is you have a geo-constrained waiver. So what that means specifically is that you can identify a certain area that you want to do a BVLOS operation, or it doesn't have to be BVLOS. It could be, this 10751 could be like a high altitude type of a request, or 51 can also apply to different, aspects of the operation related to weather minimums. So you could request to operate below the 3-mile requirement for weather restriction, and also with ceilings that are where you have a standoff less than 500 feet from your cloud ceiling. So, and what you do is you would define an area where you want to fly. You put the safety case together based on that area and put it in front of the FAA, and they will grant you an approval based on that area. The next one down is the nationwide BVLOS waiver, which is also known as a performance-based waiver. And so the way this works is the safety case, and the way we discovered this was we had generated a lot of waiver requests that were for specific regions for a few years. And then after a while, we started to identify the trends of the things that we're identifying over and over again, and that we were able to put together basically criteria that we can put in front of the FAA. So now when the FAA approves one of these performance-based requests, they're approving the process that an applicant is following, that they've defined and that they agree to follow to identify where they're going to conduct operations. And so part of these criteria that we're going to talk about is what you're going to look at. So you have to identify your risk variables. So you're identifying your air risk, your ground risk, and also your potential risk of running into obstructions. So particularly if you're leveraging low altitude shielding, you need to be aware of what is within that low altitude volume that you're going to be operating in that could pose a hazard to your operation. And then beyond that, the way you would kind of identify, kind of a common way to identify your ground risk is to look at population density. So population density, if you're below a certain threshold, the FAA will typically grant you allowance to fly in certain areas under a certain threshold. For the air risk, if you basically maintain certain distances from airfields, they'll also grant you permissions to operate, without having to have a lot of extra elements in place. Let's see. All right, so they're going back to this here. So we have extended line of sight. So this is many BVLOS waivers are in the US anyways, are technically extended visual line of sight waivers. So they're using visual observers to basically daisy chain of airspace awareness by people on the ground. The true BVLOS approvals are ones that are reliant on either low altitude shielding or some other air risk mitigation tool. So in the case of the Centero, so we have an embedded DAA sensor on the aircraft, which gives us part of our air risk mitigation strategy, but is not is not proven to provide a holistic solution for air risk mitigation in a performance-based setting. So there are applications where you could apply for geographically constrained operations where you've proven out that the air risk is very low to leverage the CASIA as your sole air risk mitigation tool. But primarily for flexibility, we haven't achieved that goal yet with that particular sensor. Finally, going down the line here, talk about high altitude. So there are operations that are, operating above 400 feet. When you operate above 400 feet, there is a bit more involved in those operations because the way a waiver is evaluated is that you have a team. It's flight standards that does the evaluations of the waiver requests that are looking to operate outside of the common rules. When you get into above 400 feet, that triggers a review from the air traffic organization. So you now have a review from flight standards as well as ATO, and those tend to actually take a little bit longer to secure. They're also, because ATO is involved, ATO is not involved in waiver evaluation processes as frequently as flight standards, so they haven't really come up with a method for doing performance-based approvals for doing operations above 400 feet. So you will find, if you were to go through the published waivers and look at 10751 Bravos, you would see that they are all geographically constrained. And typically, the waiver document itself basically shows you an area where those geographical constraints are. So, and then, going a little further down the line here, we have remote BVLOS waivers. These are operations that have become pretty commonplace recently, thanks to things like the Skydio docs and the DJI docs, and Percepto, has had in American Robotics. So American Robotics was really the first company to get this type of an approval, where they had a ground-based detect and avoid system coupled with their aircraft, and limiting it to they had tight controls about their ground hazards. And so these are operations where you could have it set up at perimeters around factories or following power lines, where you basically would have the ability to run a drone that lives in a dock. You launch it from wherever your ground control station happens to be, and you can use that as a remote inspection type of tool. So really, really slick application for drones. And the last piece is something that we're going to touch on today, is the operations over people and moving vehicle waivers. So the reality is those have been challenging to secure, and there's starting to be a bit more of a loosening about the FAA allowing these types of operations to move forward. So the original way that it went forward was you would have an aircraft that would have an ASTM certified parachute. The parachute was, a preferred method for quite a while, where that was a number of waivers were granted until the rule came out in 2021. And when the rule came out, there was a limitation, or the FAA was kind of hoping that a bunch of manufacturers would follow the rule, and the reality is not many of them did. It was the EB was your only game in town for a number of years. There has been a few declarations recently with some DJI aircraft that are equipped with parachute recovery systems that are meeting those category 2 and 3 operations. So, all right, now we're going to push on to the waiver process. This is the way Adam's telling me I got to move along here. So it's anyhow. So when you apply for a waiver, basically this is kind of the nuts and bolts of it, right? So you put together your concept of operation. You want to basically make it very clear to the reviewer that's going to look at your application so that they understand what it is you're trying to accomplish. And one of the things you need to kind of take in mind is that the people that are going to be reviewing your application probably have never operated your aircraft, maybe have never operated a drone at all. That's so you can't make the assumption that things that are intuitive to you as an operator may not be intuitive to the evaluator. So you want to make sure you spell out very explicitly what it is your operation is end to end. And then once you've done that, you want to identify the risk that are going to be part of that operation. So if you're doing a BVLOS operation, there's going to be an inherent risk of the unknown over the horizon. And that's going to be both in terms of what's on, in the air and what's on the ground. And so you want to identify those discrete areas and come up with a mitigation for how you're going to work around those areas. So if you're going to be flying in an area where you could conceivably fly over a group of people, you want to identify an alternative path that'll assure that you're going to make sure that ground risk is mitigated. So, and then once you've identified those risks, you want to go through and come up with, this next piece is coming up with the mitigations for those risk. Like I said, that a description of, alternate paths and that sort of thing. And again, these other risks that are big here is talking about, how the aircraft functions, specifically how your C2 link between your aircraft and your ground control station functions. That's a pretty big deal. And making sure that you have all of these things really clearly spelled out here. And then finally, there's this one piece. It says fill out the WSEG, which is the Waiver Safety Explanation Guideline. It is a document that you can literally, if you type in that expression, you'll come up, the FAA's guideline will come right up on their website. And so what that does is it's very plain questions that are asked for any rule that you're looking to get relief from, how you're going to satisfy the requirements following these questions. And if you answer those questions directly, in addition to having a CONOP that would probably, what you'll find is a waiver application will have some redundancy to it. So you'll have a CONOP that kind of goes through in a verbal description about how you're going to do your operation end to end. And then when you answer these waiver safety explanation guideline questions, sometimes it almost becomes a direct copy paste out of your CONOP into answering each question in a very plain fashion. And then once you've got all of that information spelled out here, these first 3 steps, you take it, you package it all together, you go into the drone zone, you enter in all the details, and you put it in there, and then it's up for review by the flight standards. All right, so some common mistakes, for waiver applications that we've seen over the years is that there's not enough information given. So if you haven't really clearly spelled out your operation details in a way that can be understood by the reviewer, they're going to ask questions. And if, depending on how incomplete it is, they may deny it out of hand. So there's that. And then the risk and mitigations, again, if you put together, like very simplistic, workarounds for how you're going to work around different risks. Like if you say something along the lines like, okay, I'm not going to fly into airplanes. That's that's the goal, sure, but it doesn't provide kind of a specific plan about how you're going to avoid your air risk. So if you're going to say I'm leveraging low altitude shielding as part of my way to mitigate my air risk, and that coupled in the case of the Centero, we have that coupled with our onboard DAA sensor that has a camera-based system that is looking for non-cooperative traffic, and then it also has an ADS-B receiver that is listening for traffic that is broadcasting on ADS-B. So you have to be very specific about what you have there. So and then finally, the waiver safety explanation guideline questions. If you don't answer those questions plainly, then you will have some pushback. So, and that's it. All right. So we're gonna highlight one of our use cases that we ran recently. This was an operation we ran in South Florida at the South Florida Water Management. So these are canals around Lake Okeechobee in South Central Florida. And in this operation, we leveraged our shielded approval. So we flew within 100 feet of the waterway here, and we used the aircraft. And this aircraft is a Centero 5, which is equipped with the Auterion autopilot architecture. And one thing, we're going to get more into Auterion here, but it's the value of Auterion in this platform is the simplicity of use. And so a previous generation of our aircraft, we were using a Pixhawk-based autopilot architecture, which, I mean, it was Pixhawk. So it was, we were leveraging Mission Planner as our front end. And while that worked, what we have found is that Mission Planner is better as a research tool in places where it can be managed pretty directly. So when you have, you know, end users that are looking to basically use something that is very simple and easy to navigate, easier to navigate. I mean, it's still, you know, the nature of our aircraft and our operations is complicated, and so, you know, the user interface is definitely a bit more involved than you would find with like a typical, you know, quad rotor, but it's certainly, you know, for an enterprise system, it's hands down one of the best systems I've seen. So and then finally, the big piece here that allowed this operation to happen was the cellular C2 link to the aircraft. So in this operation, we operated, it's 15 miles, this corridor length here, and we were able to get a long run where we had a solid connection to the aircraft. So this has worked out really well. We were able to collect some meaningful data for the end users at South Florida Water Management, and it was good stuff. So, and I'll pass it on now. So
Sweet. Thanks, Rob. Thanks for that overview. It's really interesting hearing about all the different types of BVLOS operations and approvals. So Auterion essentially is a ecosystem of software products that enable your drone operations. It enables vehicle manufacturers to create vehicles. It enables drone operators to operate those vehicles, and for program managers to manage those vehicles and their fleets. So Skynode on the left here, that is integrated inside of the Centero 5 platform. And Skynode simplifies what modules you need to put inside of your aircraft. So instead of having an independent flight controller connected to a mission computer, connected to an LTE module, we take all those modules, put them into a small box that are all integrated and connected to put into your aircraft. So we simplify things with Skynode. If we go back to the first slide real quick, Skynode is controlled with Auterion Mission Control. This is where you can fly the drone manually, control the camera settings. You can also plan missions in Mission Control. And part of Mission Control that is important for BVLOS operations is that risk mitigation. So there are features inside of Mission Control, such as geofence. You can establish areas where the vehicle won't fly to. You can set up rally points. So those are alternative landing points, say if you have a battery failure during a mission. And we also enable ADS-B in, so you can see aircraft on your Auterion Mission Control application during your operations. So Auterion Mission Control mitigates that risk. And then Auterion Suite is our fleet management software where you can track independent vehicles or get vehicle health information. So Auterion Suite will look at your logs and will identify different warnings if anything should pop up. So we have flight logs. You get a vehicle health report per flight and for the whole vehicle. You can track different assets such as batteries. So you can see your battery health, your health over time, and how many cycles are on each independent battery. Each pilot logs into Auterion Mission Control, and they have a profile inside of Auterion Suite so that you can track your flight time, distance flown, and export compliance reports per pilot. And then we have maintenance schedules, which we'll touch on in a second. But essentially, OEMs can set their maintenance schedules for their aircraft. And so once your vehicle hits a specific target, in terms of flight time or distance flown, you will get a notification in Auterion Suite in your email. Hey, it's time to check on your propellers or replace a vibration dampener or things like that. And during beyond visual line of sight operations, Auterion Suite can be used in quite a few ways. One of those are live telemetry upload. That means that as your vehicle is flying, you can log into Auterion Suite and monitor the mission live on a map, and ensure, just double check and ensure that your operations are going smoothly. And this can be done from anywhere in the world. So you can have your operators in the field operating the vehicle, and you can send a link to someone in the office who can be monitoring those operations, both of the telemetry or through a live camera stream going to Auterion Suite. And then if you are doing a mapping mission, you can have images upload live to Auterion Suite per flight, and you can have redundancy in your data collected. So it's on the aircraft, but also in Auterion Suite. We wanted to really highlight the maintenance schedules for Auterion Suite because these are defined by the OEM, but you as an independent operator, you are able to add your own checkpoints within your maintenance schedules. You can add notes, you can upload images, and all of this data compiles into compliance reports. And one of the partners we want to highlight beyond Census, so Census is using Skynode. DroneUp has based their delivery program on the Auterion platform. So with using Skynode, you have the base functionality of your drone operations handled by Auterion. That's the flight control, the the Auterion mission control, and the fleet management with Auterion Suite. But you can also work with external partners to integrate various hardware or software into your vehicle or into your fleet. So some of those examples, 2 hardware and 3 software, are the drone rescue systems. This is one of those ASTM parachutes that Rob was mentioning, to be used as a failsafe. This is an integration that Auterion provides as a part of Auterion OS. So you plug in your parachute, change a few parameters, and you have that parachute failsafe safety built in. We've also integrated with the L-Site Halo, and that is a 4-modem LTE module that uses different bands of connectivity to ensure that you don't hit any dead zones or dark spots in your cellular connectivity. So that ensures that you will always be connected to Auterion Suite or any other peripheral software that is connected to the drone over 4G. Resilient X is a real-time aviation safety management software that's running in real time, and Spleen Labs and Wonder Robotics are both precision landing algorithms. Those are one product that both companies make. And what's really important here is that you can test different softwares from different providers and really see what works best for your operations. It's really important here to note that Skynode and Auterion OS as a whole is open source, and so you are able to develop on top of it to make a vehicle that exactly fits your specifications and your needs for your operation. So that's a little bit about Auterion and what we do there.
Awesome. Thanks, Trent. That's one thing I want to add to what you were mentioning there is, the FAA right now is in the process of rulemaking for BVLOS operations. And from how things seem to be developing, in the BVLOS space, there's indicators that are showing that, BVLOS operations are going to shift somewhat, or the approvability of them are going to shift. And what we're starting to see is there's going to be, whether it's a hard requirement or just something that is going to make it easier to get approvals for BVLOS, there's leaning in the direction of better traceability. And so that traceability, comes down to training, the maintenance, and some of the elements that Trent pointed out here about what Auterion is already natively doing for tracking the assets of the, basically in addition to, tracking what's happening with the aircraft while it's flying, having that information that can be used for filling out the background information on your operation, to keep everything up to date, to be aligned with these procedures that are likely going to be coming down the road. So, we've kind of implemented procedure following not in the most consistent way, because and the rationale is because there hasn't really been clear guidance on how to do that. So and we work with many different clients, and so some of them have their own processes and procedures that they're following, and we certainly recommend our own procedures that we follow, and part of the I guess familiarization of a Centero aircraft is we have an initial qualification training that we have people go through when they procure one of our airplanes, to get them up to speed with some of the more involved elements for the process details required for doing BVLOS operations. So, all right. So that said, I'm going to close here with Flagler Beach. So this is an operation that was run. We ran this under our own waiver about 2 weeks ago. And this was ahead of Hurricane Tropical Storm Debbie that rolled through the southeastern United States the week and a half week ago, and so Flagler County is a county just north of Volusia, which is home of Daytona Beach, which is where Census is headquartered. And Flagler County was looking to get an assessment of their shoreline ahead of this storm rolling through. And so we were able to go out and conduct an operation under our waiver where we operated, and this was the approval that we had. We were operating up to 400 feet to get a big picture of the shoreline, and we were using visual observers to augment that operation. And it worked out quite well. So I see the slide actually talks about the OOP OOMV BVLOS waiver, which was used just yesterday by Flagler County themselves. So the Flagler County got their approval for operating the Centero with some abilities to do operations over people and moving vehicles in lower risk operations, including the shoreline case, which is specific for the Flagler team. So this basically allows them where they're still required to use visual observers if they're operating up to 400 feet for air risk mitigation purposes. The VOs are not required for ground risk mitigation in that environment. So that's a bit of that is a game changer, because in a lot of operations we'd run in the past, we had to steer clear of people, and we would have to basically make sure that roadways were clear before we could cross them. And so with this approval that Flagler has secured, they are now allowed to do that. They can just fly. So it's a game changer in that regard. And honestly, from my observations of the industry for a lot of years, I'm pretty confident many people have been flying over people and moving vehicles for a long time, and it's just to actually have a recognition that there's an acknowledgement that there's a high enough reliability of this system to allow these types of operations to occur in a relatively low risk in context, but still having that ability to fly over discrete roads and discrete people is a big step in the right direction for the industry, and really kind of makes the BVLOS use case that much more useful.
Well, I want to take a moment and thank everyone again for tuning in today. We are going to move into our live Q&A session, so feel free to drop any questions you have in the chat about regulations. Maybe it's about your own BVLOS or regulatory use case, or it's a more detailed question about the Auterion suite. But we did have one question. Rob, this one's going to be tailored to you. When the aircraft is detected by the CASIA system on the Centero, what is the avoidance procedure?
Yeah, so the way CASIA works is that there's two elements to it. So there's the camera-based system that is looking for non-cooperative broadcasting system. So if it sees an airplane, it'll make a determination. And what it'll do is it initially establishes a track, right? So this is all happening. There's a companion computer that's affiliated with the CASIA system that is taking the information from the camera as well as the ADS-B sensor. So when the ADS-B sensor is feeding information in, the CASIA is getting the positional information of the own ship, the drone, the Centero itself, and is basically determining whether or not there's a potential breach of well clear volume between the Centero and whatever intruding crewed aircraft there is heading towards the scene. And if there is going to be a breach, the CASIA basically sends a command from its companion computer to the autopilot to command the aircraft to do a spiraling descent. So what it does is it drops the typical value is about 100 feet. And that's programmable actually. So you can have it basically drop a certain distance and then a little loiter in place. And if it needs to drop further, it'll continue to drop further until whatever you set as the lower limit of the floor. So because obviously you don't want to have the aircraft spiral into the ground because that's not good for anybody. So.
Well, thank you there, Rob. I'm going to go ahead and throw a question over here to Trent. Maybe it's something I would like you to touch on. Rob really touched on the fact that the Auterion suite has a simplicity aspect to it compared to other flight mission control softwares. But one of the things I wanted to touch on, and we see this a lot with the Centero, is can you touch on some of the safety features when it comes into mission planning, Trent? Like when we're flying a fixed wing, one of the problems we used to have is customers accidentally putting waypoint 5 as 0 feet altitude. What are some redundancies built into that suite that help the pilot for safer operations?
Yeah, so when you're planning a mission in Auterion Mission Control, there is two things I'll touch on. One of those being it gives you a flight time estimate based on how many waypoints, the speed that you're defining, the altitude, and it will give you an estimation. So if you know the flight time of your aircraft, you can ensure that the missions that you're planning are within that time frame of your aircraft. The second way that Auterion Mission Control helps when planning missions is by analyzing the altitude of the land that you're flying over. So we've got satellite tiles in Auterion Mission Control that contain elevation data. And if you plan a mission with waypoints, maybe not even at 0 feet, but maybe at 5, 10, maybe even 100, Auterion's Mission Control will alert you, hey, you're going to fly into the ground. And if you're planning missions on your computer on Auterion Mission Control, you can actually view your flight in 3D space. So that's another way that you can ensure while you're planning missions that you have a safe operation. And we actually are about to be launching our Mission Cloud Sync. So that is a feature where you plan your missions on Auterion Mission Control on your computer that uploads into Suite. And when you turn on your vehicle in a location that is near one of your missions, that will pop up and you can execute that mission when you are in that location. So there are lots of mitigation features built into Auterion Suite. And then, of course, there is the ability to view your flight afterwards in 3D, again, to check for any anomalies and just ensure the aircraft is operating in the way that it should.
Thanks for that, Trent. The next question is for you, Rob. And I'm going to add a little bit to this one, but how can you mitigate risks for aircraft that are not transmitting on ADS-B? And Rob, maybe take this time to maybe just touch on like 2 or 3 different DAA options out there.
Okay. Okay. So, right. So so we have a DAA sensor on our aircraft, and if the intruding aircraft is within our field of view, uh, everything's okay. And there's a reason, the sensor faces forward because of, that's the kind of the worst case scenario of an encounter. And in that regard, it actually works quite well. So, however, it's true, it's not going to capture everything. And so there's a couple of ways that you can go about mitigating those risks with non-cooperative traffic. And what we've done for the operations that we run currently is, if we are running up to 400 feet, we're leveraging visual observers to augment our airspace awareness surrounding the flight path that we're flying along. In addition to that, we've been looking at different tools to augment our airspace awareness. And so right now, we've been working pretty closely with Canadian UAVs, and they've developed a product called Sparrowhawk. And Sparrowhawk is it's a radar system that is X-band that is used for getting a picture of what's happening in the airspace around where you're operating at. So that's a ground-based sensor that can be used. There are other, vehicle-borne sensors that have been proven to be a bit more effective at longer ranges. At this stage, the challenge is the integration on smaller aircraft, particularly aircraft that are operating under Part 107 that are under 25 kilos. These systems tend to have size, weight, and power constraints that make them challenging to integrate. So there's ways to do integrations of systems that are ground-based or air-based, or leveraging in the case of different states around the country are putting up sensor networks, right? So you have, what is it? Thales has been working closely with North Dakota, under the Vantis network to establish, big corridors where they've got ground-based sensors that are giving airspace awareness that could be, you basically pay for your time that you're going to use it as an operator. So there's a lot of different ways to get there, but it's still in the early stages, I would say, at best. So it's we've come a long way, but we've got a long way to go for understanding how to mitigate non-cooperative traffic.
Thanks for that, Rob. And
Yeah.
Brian says thanks as well. I wanted to pass that along. I have another question for you, Rob, but it's actually about Auterion. So Trent, if you want to hop in after, feel free. But as UAS operations evolve, and we'll probably see one-to-many become very popular. How important is it to have a system like Auterion where you can monitor the drone health? I know Trent kind of touched on that earlier, but when you start operating that one-to-many, how important is that going to be?
It's going to be absolutely essential. So what you're describing is kind of a blend of what's happening with remote operations, right? So, one-to-many could be fully remote, or it could have people in the field managing those one-to-many operations. And, and one could imagine a ConOp where you have like a single pilot, managing the launch of, say, 10 aircraft or 20. And then, with something like Auterion running as the ecosystem on each of these airframes, you could have that single pilot there kind of managing the ground, situation, and then have like, remote operators that could be overseeing the overall operation and have kind of designated people that would fill in for having to recover an aircraft that might be, not performing the way it's supposed to be in that operation. So it is definitely a really valuable tool of having that level of oversight, and the fact that Auterion's integrated in at this stage before it's even necessary for a lot of operations is it's good, because they're getting the information or the data on how the systems work now, and ideally getting themselves ready to hit the ground running when the requirements are real.
Yeah, and to add to that too, we are working on various multi-vehicle control methods, both in Auterion Suite for actually command and controlling the vehicle, but also in Auterion Mission Control, and then in Auterion Suite. So within Auterion Suite, say if your fleet has, this is currently how it is. If you've got 5 different vehicles and 3 of them are flying powered on and flying at the same time, your main dashboard in your company will display those vehicles, and it will display the telemetry from those vehicles live. So you can watch the telemetry on a map, or you can even make a dashboard of all the live streams from different vehicles and be able to present that in an office for monitoring your operations remotely. So there is the infrastructure built within the Auterion ecosystem to support many different vehicles, both from a command and control side in Auterion Mission Control and from a monitoring side in Auterion Suite.
Slick.
Awesome. Thank you, Trent. And I'll kind of get another question here. Either Rob or Trent, you can take this one. Here, let's start with Rob, and then Trent, you can kind of follow up here. But all the waivers that Rob has gotten for Census Technologies, Rob's is the name on the top of the piece of paper. So as BVLOS scales and more teams are operating under their, the same kind of waiver, Rob, how important or nice is it to be able to kind of check in on flight teams that can be operating across the country to make sure that they're staying within the waiver?
It's essential. I mean, to have that level of accountability is important, and certainly, kind of back to the conversation about the future BVLOS rules. There's an indicator that there's going to be permits that'll be granted to operators, so it won't necessarily be an individual responsible person, but rather an organization. And at that point, having your process, and again, talking about processes, is that's going to be an essential part of it, is to ensure that your pilots are current, that they're following the procedures properly. Is like all of that stuff is going to have to be traced. And so, having that insights, which I think is what we've already touched on here, where with Auterion has it in place already, is going to be essential down the road. So,
yeah, I'd also add that in Auterion Suite, you can upload your compliance information. So whether that's your Part 107 certificate, your PDF of operations, your waivers, you can upload all these compliance documents into Auterion Suite, and those will now populate within Auterion Mission Control. So say you're getting ramp checked, you need to bring up a flight authorization. Maybe you're in a Lance zone. Those documents are stored in Auterion Suite and are accessible in Auterion Mission Control. So it's another way to ensure that you have all your compliance documentation all in one place for your operation.
Yeah, that I didn't actually realize that. That's pretty slick, Trent. It's so just to kind of follow up on that, right now the performance-based approvals that we hold and that some of our clients hold, there's a requirement for them to have for each area that they elect to do a BVLOS operation in. Well, they have to make a determination of the suitability of that area for doing BVLOS. And part of the process of determining that suitability is to make a report. So a number of the waivers that have been granted, actually specifically the FAA is citing that each operator needs to have an area selection analysis for each location that they do BVLOS in. So having that be able to plug in Auterion is it's a nice feature. So it's good stuff.
Yeah, that is also a feature I was not aware of, so I learned something new here as well.
Right. You would be both. Yeah.
I'm going to give everyone the opportunity. I'll give Rob and Trent here a couple minutes to do a closing statement if you have anything else to add. But if anyone else has any questions, this is your last chance to drop them in the chat. All right, here's one maybe from Bobby Valentine. So before we get there on the closing statements, Rob, on average, how long does the approval process take for a performance-based BVLOS operational waiver?
I mean, it really depends on kind of what's happening with the team that's doing the evaluation. So I've seen it go as fast as 30 days, and I've seen it take as long as 90. So it's somewhere in the middle. And I think right now we're probably trending somewhere in the 60 to 75-day range.
And Rob, just to expand on this a little more, once someone has a waiver, can you kind of touch on the amendment process?
So the amendment process can go faster conceivably. It really depends on what it is you're looking to do. So if it's an amendment where you're looking to change your con-op, then it pretty much gets evaluated as a new waiver request. If it's an amendment for, an administrative change, so we've had a number of clients that we've worked with where, one person has applied for the waiver, is a responsible person. That responsible person then goes to a different organization, and they simply want to transfer the responsible person from, the person who left to whoever the new person is that takes over that particular approval. And in those cases, those types of requests can go in and be turned around pretty quickly. So they do have a way you can identify when you make that application in the drone zone, because the reality is there's not like a specific amendment button that you press in the drone zone. So you're filing it as a new waiver, but you need to identify it within your waiver request that it is an amendment. And so that's how the recognition is made of how you're filing an amendment.
Thank you for that. And I think that's all the questions that we have from the chat. So, Trent, if you want to start off with any closing statements, feel free. And then, Rob, if you would close us out, we'd appreciate it.
Yeah. Thanks, Adam. I just want to say that if you've got an Centero, if you're flying beyond visual line of sight, and you're using Auterion Mission Control currently to operate your aircraft, but you aren't using Auterion Suite, I would highly recommend scheduling a meeting with us so that we can go over Auterion Suite with you and discuss the many different ways that it can help you improve your operations and make sure that you're staying in compliance with the many different regulations you have to comply with. So reach out. We'd love to help you out and answer any questions that you might have.
Awesome. Thanks, Trent. And so, thinking about BVLOS operations, I've been thinking about BVLOS operations for a long time. So, I started in this space in 2015 with an organization where we were looking to do remote operations. And that organization I worked for was granted one of the first remote operations where the aircraft was in Arizona and the ground control station was in Boston. And that was in 2017. So it was, had to have people involved, for managing air and ground risk at the site, but it was truly remote. And it's exciting to see that, the industry is really getting a lot of traction. And the point I want to make is BVLOS operations are hard. They have been they're just challenging. It's just, like if I wanted to right now, I could step outside, my house and I could run a VLOS flight without even having to think about it, really. It's just, it's very straightforward. For a BVLOS operation, there's a lot that goes into it, so in the case of these performance-based operations we've talked about here, the planning for, a single hour flight could take, 8 to 10 hours, for an initial operation. So, and there's just a lot more groundwork that needs to go into it. So I guess that's the thing I want to really kind of emphasize is that it's a step change. So if you're running, drone operations, within Part 107 requirements, getting to BVLOS it's not easy, but it is achievable. But it's just, so it's a challenge, and there's ways to get there. And hopefully, some of what we've covered today kind of gives you some insights about how it's done. But don't expect it to be a simple thing to do. So.
Well, thank you again. Oh, Trent, you got something? Go for it.
Yeah, and I was just going to say thank you to Census for putting this on and really doing this series of webinars that will help anyone really looking for guidance on how to start their beyond visual line of sight operations. So thank you guys for the work that you are doing. It's great to be a partner with y'all, and yeah, thank you very much.
Well, thank you for those words, Trent. I really, really appreciate it. And once again, I just want to thank Trent and Rob for taking their time and coming on here and sharing their wealth of knowledge. If you guys have any questions about the Auterion suite or regulations, feel free to reach out to Census or Auterion, Rob and Trent as well. Feel free to email me if you need be. And thank you again to everyone joining today. We are hoping that this educational series will be a biannual event as regulations and technology rapidly changes. So be on the lookout for future updates, and have a great rest of everyone's day and week.
All right. Thanks, everybody.
Thank you all.